Hello everyone, I'm Mitchell Gresham. Today we are going to be building a simple rocket in OnShape. This isn't going to be anything super duper complicated. This first video is going to be covering everything from body tube design to the nose cone design to then putting fins on the body tube. And from there, you should have a solid rocket. And in the second part, we're going to be going over a more complicated part of this, which is just motor. Implementing a rocket motor into it. As you might guess, rocket motors are pretty powerful, so creating a system that can effectively hold them deserves its own video. So let's just jump right into it. So we're going to start with the simplest thing, body tube. I like to always name my things. Some of my projects that I've just like quickly thrown together haven't really had very descriptive names, but if you have the time, it will save you a lot of trouble later on just naming things as you do them. So starting off, what we're going to do is pretty much just make a simple tube. Make a sketch. There we go. I like to get rid of all these other axes. It just makes it easier to see what I'm doing. We're going to make a center point circle right on the origin, right there. So right now these workspace units are in inches. This is 2 inches big. I like to work in millimeters usually for making rockets. So as you just saw, you can change it pretty easily to millimeters. And then if I go back into that sketch and do dimensions, you can see it's in millimeters now. So let's say we want a 20 millimeter wide body tube. Well, if we want 20 millimeters to be the outside diameter or the inside diameter, it's going to depend what we do on the next step. So I want 20 millimeters to be the inside. I'm fine if it's 21 or whatever on the outside. I just want 20 millimeters inside. How we're going to make the actual tube is we're going to use an offset on the outside and determine our wall thickness right here. I usually stick with 1 millimeter. You can go 1.5. Probably wouldn't recommend more than 1.5 based on my experience, but there is, as you can see, kind of an outline of our tube. And we can name it something, main body tube, tube. Perfect. We're just going to make an extrude of this body tube. That wasn't meant to rhyme. Let's say we want it to be 150 millimeters long. There we go. There's our body tube. Let's make this 200 just for funsies. I like building rockets that are long. There's our main body tube. It ain't much to look at right now, but once we put the fins on it and eventually put the motor mount, it's going to look like a pretty cool thing. I almost forgot to name this extrude right here. I like to name them the same thing if they're doing the same thing. So this is just extruding this sketch. So I just name it the same because you can tell on the left-hand side whether it's a sketch or an extrude. So I usually don't take the time writing the word extrude or sketch in there. But anyway, this is step 1 toward building the rocket. Step 2 is we're going to need a nose cone, something to fight against the air as it shoots into the sky, but also something that can pop off the top for when we need to deploy the parachute. So, nose cone. And quickly speaking on nose cones, if you are kind of confused, like why we need a nose cone, why we need fins, why all that, I might mention it in the videos, but I won't explain much. I would recommend checking out STES. They make some great video content on YouTube regarding actual rocket design itself. This is just going to be designing a very simple one. So let's just jump right into nose cone design. We know that the base of this nose cone is going to have to be a circle. And we know that the inner diameter of our rocket is 20 millimeters. So we want it to be flush with the outside. So we're going to do 20 plus 1 for 21. I know I'm pretty good at this. Don't applaud yet. As the outside of the nose cone. we're going to use an offset, but this time we're going to make it on the inside, and we're going to make it more than 1 millimeter for the reason that we want it to fit into the body tube. And my 3D printer is not good enough to get sub 0.1 millimeter accuracy. So I usually like to do something like 1.2, maybe even 1.3, depending on your printer. And I would recommend just printing out some test parts of like simple circles and cylinders and seeing how close it can get. Usually 1.2 works out perfectly fine for me. We can go ahead and do 1.3 just for testing, because it's better that it's too small rather than too big, because you can always add tape and make it thicker, but you cannot always sand down everything and make it smaller. Rocket body tube base, or sorry, rocket nose cone base. There we go. And now we need to make a shape. We need to make a cool little rocket nose right here. And the way we do that is we're going to unhide all those planes that I hated looking at. Let's choose this front plane. You can also choose the right plane optionally, but it doesn't really matter as long as it's not the top plane. So let's make a sketch on the front plane, and we're going to make the shape of the nose cone looking at it from this way. How we do that is first we're going to define its height. So it's going to be something like this. And let's say we want to make it a pretty decently sized one. So 70. This rocket's going to be 270 millimeters tall in total. That's pretty big. So now we have that. We're going to use a conic over here and connect this, or let's make a conic. Doesn't really matter if it's blue right now. We're going to attach this point right here to the edge of that circle right there, the pierce feature. That doesn't look like our nose cone right now, but we're going to fix that. We want to make this line black. And the way we're going to do that is with some more lines. This time we're going to use some construction lines. Construction lines are like other lines. They just make sure that it's not actually accounted for when you're extruding. So let's make this something like 10. And that looks 7. That looks reasonably like a nose cone. You can adjust this row to make it sharper. So like a 0.2 would be like a very sharp nose cone versus like a 0.8 would be like a very dull one. We're gonna go like a 0.7 because I think that just kind of looks interesting. I haven't really made a rocket with a really dull nose like that. So that's gonna be what we do for this series. And we're gonna name the sketch rocket nose cone side. Probably be a pretty decent way to name it. And the last thing we need to do here before we leave is we need to do another offset on the inside. And we need this to be 1 millimeter. It's going to be probably the same thickness as our rocket. This is just going to be the width of the wall of the nose cone itself. You can make it thicker. Sometimes I like to make mine thicker, so sometimes I like to do 1.5 just because if the parachute doesn't deploy, this is the part that slams into the ground, but that is up to you. Make sure you actually make this into an object, and the way you do that is by connecting these lines down here. And we have a shape. Now how we make it into an actual nose cone is with the revolve feature. So we're going to revolve this around that. And we get a nice little nose cone looking thing. We're going to add to that nose cone and make a little area right here so it can stick into our rocket. So we're going to use an extrude for that, facing the opposite direction. And 25, let's do 30. That seems decent. What I like to do is I like to do a second imposition and make that second imposition inside of the actual rocket right before it starts sticking out. Just like that. Make sure you name the part. And let's go back to body tube and make sure, because I know we didn't name that part. There we have our body tube. And we have a pretty good looking nose cone that will fit perfectly into our body tube. Okay, so as promised, the next thing we're going to make is the fins. So we're going to make rocket fins, even though we're only going to be designing one fin here. And the process for designing these fins is actually very similar to the process we use for designing these nose cones. The way in which we're going to do it is we're going to start off by making its base. So we're going to make it kind of an airfoil design. An airfoil design is kind of a design that just goes like that. It's kind of hard to describe without showing, so I'll just go ahead and jump right into showing it. So we're going to make some lines. First, to determine the height of this fin. We don't want it to be too big. Let's say 60 or 70. By the way, these numbers aren't like, shouldn't be consistently followed. These are kind of arbitrary, just showing the process of designing one. We're going to do two conics, just like this. It doesn't really matter if they're attached right now. Get out of here. Then what we're going to do is we're going to attach these points to the end there and there. Kind of have a teardrop shape right now. We're going to identify the midpoint of this middle construction line, which turns out to be right there. Then, on both sides, we're going to determine how thick we want this fin to be. In this case, I want it to be, let's say, 6 millimeters thick. So what that means is we're going to, on both sides, make this 3. Then intersect that point with the curve from the coincide or whatever the heck it's called. Apologies. And we have what is starting to look like the base of a fin. Of course, we don't want this going on up here, so we're going to make the lines blue by making some more construction lines up here, and we're just going to bind these like points that are just floating in space equally on both sides so they don't make a not symmetric shape. We can do 10 or something. And then just coincide those two, or I guess maybe not. Sometimes 10 is a little bit too aggressive to start with. There we go. Okay. So it looks like, as a result of this 3 millimeter fix thing right here, this has to be approximately 7.24 whatever. And we're going to do the same thing on this other side with that point as well. We're going to go until that yellow line matches up. And then we're going to change this line to, okay, you know what? We're done with these lines. These lines are causing us more trouble than help, so we're just going to get rid of them. As you can see, the line is black. We just have to make sure that we get that that one line to be level with. As you can see, we want this little line to appear, which means it's perfectly parallel to this point right here. Same thing on this side. Okay, so now we have the body, or the base of our fin. We're going to name this something like fin base, in previous image. And now, in the same fashion in which we made the nose cone, we're going to choose a plane, front or right, and make a shape that we want on this axis. So it's going to be like a curved shape, kind of like that. So the way in which we're going to do that is starting with a line. This is going to determine the height. So let's say we want the height to be something like 50. Let's get a little bit more aggressive. 70 looks good. We're going to make two conics on each side. Connect those conics to the vertexes that determine the base of our fin. Connect those together. Then make these fixed. Decent positions. I think here we'll be able to use our constriction lines that I was trying to show in the last part of this. Yeah, we will be. So now we have a fixed distance for those black lines. And you can change this again to be closer to the center or away from it. I usually like to do 0.2 for this. I feel like it just makes it a little bit more aggressive of a fin. I think it looks pretty cool. But you can choose whatever. It's like 0.8 would be a pretty dull fin. I wouldn't recommend doing that. But 0.2, 0.5, 0.6 works fine. So now we have that part, the right looking side of it, I guess you would say. And we have almost what looks like our fin. Now the last step is we're going to be using something called a loft. And we will be selecting this surface up to that vertex. As you can see, it starts to make the fin, but we don't want it to be a perfect triangle. So we're going to go to the guides, and we're going to use those lines that we just made as guides for that loft. And as you can see, we are left with a pretty cool looking rocket fin. Let's go ahead and name everything just so we remember. Again, it saves you a lot of trouble later. That's decent. And then this can just do fin loft, something similar. And there we go. So now we're going to put these fins onto this body tube right here. So the way we're going to we're going to do that is by using a derived part. So a derived part just moves a part from a different assembly into the assembly that you're currently working in. So in this case, I'm going to derive 3 of these rocket fins, as you can see here. But as you can also see, we don't want them to just be sticking there. That doesn't look like a very good looking rocket. So we have to transform them. Not anything crazy. We're just going to be rotating them. Rotating them so that it is parallel to the wall. Not to the wall, but to this. And we're going to go ahead and stop doing what I'm doing real quick and make a line that goes from here to here, because as it stands right now without that, we're not going to be able to actually do anything. I believe it's this plane we're working in. Yes, it is. Okay. So just a quick detour. We're going to make a line that is in our axis. We don't need it to be anything super duper pretty. We can just name it this. And now you can see when we go to transform, instead of me sitting here looking confused, we can rotate this part on that axis. In this case, we want to rotate it by 90 degrees, giving us that. That is inside our rocket, and we don't want it to be inside. So we're going to transform it one more time by XYZ. We know that the inside is 20, so we can go ahead and move it out by something probably close to 20, or half of 20, so probably 10, negative 10. That looks good to me. Then we're going to move it up into the rocket, something like that. In this case, it looks like translating it up by 80 would be a pretty good, 80 or 70 would be a pretty good choice. And we have our first fin. Right now it just kind of looks like a weird shark. We're going to repeat the process for each one of these fins, rotating it by 90 degrees, then transforming it again, and moving it up by negative 10 and 70, I believe is what we used. Yes, 70. One last time, we can go through this boring process of just rotating them 90 degrees. And if you were doing this, I'm trying to make this quick so you guys don't have to sit through me doing this all, but in reality you should be naming all these just kind of a general description of what you're doing. So like moving fin 3 or whatever. Usually I would name these things like fin 1, fin 2, fin 3, and then that's easier to work with. But for just this tutorial, it doesn't make a big difference. Okay, and now we have 3 fins, but 3 fins existing at the exact same place. And the way we're going to solve that is with our best friend, the transform, one more time. We're going to select each fin, and we want it to be not symmetric, but symmetric across some line. So we're going to make 3 fins, and they're going to be 120 degrees apart from each other. We want to rotate it based on this outside axis right here. Rotate it by 120. One more, transform. We're going to rotate it on the outside axis, this time by negative 120, so it's on the other side. And you can see we have a rocket with big fins. I didn't realize how big those fins would be. Usually you don't want your fins to be that big, but a rocket nonetheless. And we could change this by adjusting the height in rocket fins and width. But right now we have 4 different parts. Obviously we don't want to print 4 different things that are inside each other. That sounds like it would be a mess. So we're going to use something called a Boolean to just make all these parts be one part and make them all friends. Now, as you can see, they all became friends and everyone lived happily ever after. So, despite this looking like some melee weapon, we have a rocket body, rocket fins, a nose cone that's going to fit onto our body tube, and we have one thing left to make, and that is going to be the mount for the motor. We also should add a parachute thing in there, but that's no more, no less. That will be in part 2. Thank you for watching part 1. I hope this was informative. Thank you for watching me struggle through designing rocket fins. Hopefully this was some guidance so that you don't have to. Have a great day.